Hi, I'm Bill Reinert. I'm National Manager for the Advanced Technology Group at Toyota Motor Sales USA.
Bill, a couple of years ago we talked about Well-to-Wheel, and you're one of the people that really understands Well-to-Wheel.
Sure.
How are we doing in Well-to-Wheel? What is Toyota doing with Well-to-Wheel?
Well, beyond Well-to-Wheel, what Toyota has established is a life cycle assessment program that I'll show you later, and it's called EcoVAS within Toyota. And basically, it measures all of the inputs, environmental inputs, that go into the whole life cycle of the car. And now our chief engineers are given an environmental budget, just like a cash budget, to design their cars. And each new car has to impact the environment less.
So whether it's carbon fiber they're using or steel or the whole gamut from well-to-wheel to making it the whole production of the vehicle.
Right, the whole life cycle of the vehicle, from the materials we use to the production techniques we use to how we, of course, we're still interested in good fuel economy, to how the car's maintained, and then also to how we recycle the car, and we're also designing our cars to be recycled.
Let's look at some of the charts that you've shown us before and go through what you showed us 2 years ago and see if anything's changed.
Sure.
Now, the piece we have here, what is this slide?
Okay, Luann, this is a slide you should be pretty familiar with. This is the well-to-wheel slide that compares the energy efficiency, that's the making of the fuel and then how the fuel's used in the car, compares that of a hybrid vehicle or a fuel cell vehicle. And what you can see is a hybrid vehicle is essentially twice as efficient, actually slightly more than twice as efficient as a gasoline vehicle, and that a hybrid fuel cell vehicle is about 50% more efficient than a straight fuel cell vehicle. But that our hybrids right now, our gasoline hybrids like the Prius, are just about as efficient right now as our fuel cell vehicles.
Is that because of the battery making or something?
No, that's because of the inefficiency in the well to tank. And if you look over here, the ability to make gasoline is a pretty efficient process. We've been doing it for about 100 years, and we pretty much know how to do it. Making hydrogen, on the other hand, either from natural gas or from electrolysis, isn't quite so efficient yet, and that's where we really have to focus. And as you see, Toyota's targets are a 70% efficient hydrogen production process, a 60% theoretical efficiency on the fuel cell hybrid, for a combined efficiency of 42%, which is beyond what we can realize with today's gasoline examples, and that's why we're working on fuel cells.
And you were talking about EcoVAS as well.
Well, let me go into that. So this is just one way of looking at it. And well-to-wheel is measuring the efficiency and the emissions of the energy in the fuel source from the well to the tank to the wheel. Okay, so we know that pretty well. We've talked about it for 2 years, and we're pretty comfortable with that. But when you look at the way that cars are made, we have materials for production, we have the actual production process, then the driving, the well-to-wheel, then the maintenance, and the disposal. And all of these have inputs into the environment. They all have inputs in the environment, and they all affect the environment. So we need to measure the environmental impact of each of these processes. So let's look a little further. We've been talking about driving, and then these are the inputs into the whole cycle, natural resources and energy. And the outputs down here are vehicle emissions, greenhouse gases, wastewater, waste solids, and air pollution. So if we dig down a little bit deeper, here is a life cycle assessment from materials production. And if you look, a lot of people want us to make our cars out of carbon fiber. Carbon fiber's lighter. It makes our cars get better fuel economy, correct?
Power to weight ratio.
Sure, it's all great. Until you look at the current ways of making carbon fiber, which include an autoclaving process to cure the carbon resins in there, or to cure the resins in the carbon fiber. And that's incredibly energy intensive. And if you look at this, the CO2 emissions from the carbon fiber process are much higher than the CO2 emissions from the mild steels and the advanced steels we use. And in fact, the CO2 emissions from the carbon process are so high that you never recover that energy from the increased fuel economy because of the lower weight. And that's one of the main reasons we don't go to carbon fiber yet.
Where's aluminum?
Aluminum's over down here, new aluminum ingots. That's refining aluminum from new ingots. But if you look down here at recycling aluminum, there's almost no energy used in that. So what we really want to do is to recycle more and more and more of the aluminum. So go take your tin cans to the recycle center. It's very important.
Now, what about steel? Don't we still use a lot of steel in cars?
We do use a lot of steel, and that is, let me see here. That's down here, stainless steel, cast iron, and carbon steel. They're down in the very low areas down here. And we're getting better as we go to the new modern composite steels.
You know what I noticed? A lot of what Toyota is basing how they build a car on really has nothing to do with the car, but the production of everything that goes into a car.
Well, it's not that it doesn't have anything to do with the car. It has everything to do with the car. But we look at the car as more than just the motor and the body, but the components that go into it and how you make the car. In fact, our plants here in the United States don't impact the landfill. We have a zero landfill impact policy with our plants. So
now, I knew Subaru had zero landfill, but I didn't realize Toyota
we're
did.
putting that in place too. We don't impact the landfills.
Bill Reinert, it's always a pleasure to talk to you. Thank you very much.
Thank you, Lou Ann.